All right, so this is video 1 on the first one we're going to do. You don't need to bother about the name, okay? You just need to know for your information it is the Artwood machine. All right, hi guys, Chris here again. Okay, now let's see how we can resolve this. Whatever you're doing in connected particles is only equals to F is just equal to F is equals to ma. Don't forget that. F is equals to ma, Newton's second law of motion, or Newton's second law. Okay? All right. So this particle is going like this. So I will do, this is the direction. Now you have to resolve this. So to resolve this, you need to find the weight. So this is m2g. Weight is mass times gravity. So mass mg. Similarly, all objects have weight on Earth. If you're in the moon, it's different. You cannot, there's no gravity there. So here, even if you're accelerating upward, your weight is down. So this is m1g. So from here, I'm just going to resolve. And now, imagine you're doing tug of war. Okay, as you're pulling the rope, just after your hand, there is a tension on from the rope, action and reaction. So for every action, there's an equal and opposite reaction. For every action, there's an equal and opposite reaction. Don't forget that. So this will be for M2. So I'll write M2. So this will be M2G minus T. So down minus up. So I'm considering here. If I was considering here, I will go like this. So I'm considering here. So down minus up is equals to MA. So this is my first equation for M2. For M1, this is going like this. So this comes down, this goes up. So this will be T minus, this will be T minus M1G is equals to, this is M2A. From here, I believe you know how to solve simultaneous. So if you're giving the mass, just put the mass. If you're giving G, depends. So G can be 10 or 9.8 or 9.81, depends. Anyone you use, you get close to the answer. So you watch your instruction or your syllabus tells you which one to use. So from here, it's easy. Just solve. You're giving M2, you're giving M1. Solve simultaneously. So this is the first case on how we can resolve. So the direction matters. So if I was going like this, this would be this minus this is equals, so these signs will change. So if I was going like this, it would just be opposite direction. All right, guys, have a nice day and take care of yourself. Guys, Chris here again. So we're on our quest on connected particle masterclass. Okay, this is a comprehensive summary of connected particles. You're preparing for your exam, trust me. By the time you finish watching this video, you will be very good. You'll be an expert in resolving forces with examples, okay? All right, so we've done the first one. You can check the previous video. And now we have two particles, no friction. So after this, we'll do friction. So for no friction, again, like we did it in the previous video, we said, now the weight of this will be M2G. The weight of this will be M1G. Don't forget that. Action and reaction. Now this, how do I know the direction I'm putting here? Whenever you have a string, it will always be like this. This is the right one. For this, not possible. So it will always be opposite each other. All right. Now the next thing, so this will be like this. So imagine they are going, so they like cancel out. So this is T, this is T. No friction, remember. So for this, it becomes M2G. The particle is accelerating down. Minus T is equals to M2A. This is my first equation. Now, for this, so this is where everything stops. For this, what do? This will be T minus, there is no friction. So it's like 0. There's nothing hindering it from moving. It's equals to M1A. So you see, we're just using F is equals to MA. So this is the same thing as T is equals to M1A. Now they might try to trick you. What is the resultant of the strings? So I'm just giving you for your reference. So the resultant will always come from here. So the resultant will just be, so you can see it, we're using Pythagoras theorem, this and this. So square root of the strings. So square root of T squared plus T squared. This is the resultant. Okay, so it just, so this is this is this. So I'm just finding the resultant of the string. So if you have any doubt or you feel there's something wrong, just type in the chat and I'm going to answer you. We're going to tackle the case where there is friction. F is equal to mu r. Just remember it like that. It becomes easier for you because you know you need to find r. Okay, so this is our answer for no friction. So I'm just going to erase this. Little changes, but it's very important we know how to do it. Okay, let's get to business. Again, this will not change. So this becomes M2G minus T is equals to M2A. This will not change, but here is going to change. So this will be T minus mu r. So like this minus like this is equals to M1A. Now what is r? That is the question. If you don't write it like this, some people write F and they think F is equals to MA. No, this is the frictional force. And action, in the first case, I didn't put the reaction because I didn't really need it because there was no friction. So action, this is R. So R is M1G. So this becomes T minus mu M1G is equals to M1A. So this is my equation when there is friction, or in the case of friction. So it's very easy. It's just for you to, this is how I think in exam. So once I know the direction, downward minus upward is equals to MA. If I'm going like this minus this is equals to MA. So I believe you can now see how we are getting these answers. All right, so from here, I believe you should know how to solve simultaneous equation, either substitution or elimination. From here, it's easy. We're going to do example. Watch out for the video. Now what are we learning? Now it starts to get a little bit tricky. So we've done the pulley system, okay, which is the Atwood machine. Then in the second case, we did the table and one on the table, one hanging down the table. Then the third case, that case was for no friction, and we did also for friction. So you can check my bio for the videos. Very important you understand this. Your exam might be tricky. Okay? All right. So now we're looking at table, one hanging on both sides. How do we resolve? So first, we'll do no friction and friction so that you see how it is. The first thing, always write, this is the weight, M3G. This is M1G. This is M2G. This is, okay, for now, this is R, okay, just take it as R is fine. Okay, first, I am assuming the particle is going like this. So this is easy, this is easy. So this becomes, so this is action and reaction. Remember I said these two must oppose each other. Then, which direction do you think this will go? Now let's see. Just Remember, this is going like, so this is the one pulling this. This is going, even if you don't know what is here, I will tell you. This will be here because action and reaction. Now I told you it must oppose. So what is actually happening is this, just after here, there's an opposite force, action and reaction. This is pull. This is the force that pulls this, because without the tension, this cannot go. Now, as this is pulling, just after here, there's an opposite force. The same thing here. So it's very important you draw the arrow properly. So another thing we should note, this is T1. This is T1 because it's the same string. Now, don't assume that these strings are the same, except you're told. So this is T2. This is T2. So they are different strings. So this part is the same, except you are told the string connecting M1 and M2 is the same, and M2 and M3. You can assume it as T. But in most cases, they are not the same. Take note of that. All right, so let's do for M3. For M3, it is M3G minus T1 is equals to M3A. This is my first equation. This minus this. Then for M2, okay, let's do M1 first. At least you get marks. Okay, that might be tricky. So M1, what do? This is going like, so always consider the direction. That is where most of you make the mistake. So this is going like this. So if you want to, you can write, you can put the acceleration. So this will be T2 minus M1G is equals to M1A. So this is my second equation. Now let's come to the big boss, M2. For M2, since there is no friction, it is T1, this minus this, no friction. There's no friction. T1 minus T2 is equals to M2A. So this minus this. If there was friction, I would just add mu r here. That is it. So this is the thing I need to know for connected particles. This is 3. This is one of the a little bit tricky. It starts to get a little bit harder here. So this is my answer to this question. So from here, sometimes you'll be giving M1, M2, M3. Then you're giving, G, and that is my answer. So don't forget, direction matters. Direction matters. And case 5, there is friction. This is no friction, okay? Don't look at this, is not the answer. So here, there is friction. Remember, friction opposes motion. So friction will be, just always write friction as mu r. It becomes easy. Don't write F, because you will assume F is ma. So opposite. So because this is coming down, when this moves opposite, this will remain the same. M1 will remain the same, but M2 will not remain the same because there's friction. So this will just be T1 minus the friction minus T2 is equals to M2A. And what is R? R is mu M2G minus T2 is equals to M2A. So this is my third equation. This is, once you understand no friction, then you just need to add mu r. So this is my equation for resolving this, or we call it drawing a free body diagram. So if you have any doubt, this is a masterclass, trust me. By the time you do this, you will understand what we're doing. All right, guys, have a nice day, and don't forget to share this video to your classmates. Don't forget to share this video. It's very important you share. If you don't share, it means you're keeping information for yourself. Okay? Try to share and you discuss. That is the only way you can understand. When you argue with your friends about a particular topic, you understand that topic. We are in inclined plane. These angles can be different. I think I will make it different. So let me call this theta 1 and theta 2. Yeah, let me make it different. Okay, this particle is accelerating to this direction. Okay, now what do we need to know? If you are not used to inclined plane, it is very important you understand how to get some constant in inclined plane. So I'm just going to do a refresher for you guys. Now for inclined plane, this is what I have. So if I have a particle here, there's a force that will bring this particle down. So normally we do this. So this is the weight of the particle, mg. This is m. And this is my normal reaction. This is r. And action and reaction are equal. So there's something here. So if this is theta, I think I proved this in one of my videos. I'm just doing a refresher. So if you understand this, you can fast forward the video and see how to do this one. Okay, next, this particle will always come down. Which force brings it down? Now let's see. So this angle is here. This is theta. Believe me, okay? This is theta. If you want to know why, just send me a message. I will reply you. I will make a video, or I can explain, solve it, and send to you. Now, if I make a 90-degree here, this becomes, so this is sine theta is opposite. So let me call it x over mg. So this will be mg, if you cross multiply, sine theta. So this is the force that actually move this particle down. So it's not just so this is the force. So the particle does not just move down on its own. So it's sliding down, but yes, this is the math of physics behind it. Now, if I do the same thing, here will be mg cos theta. So my r is mg cos theta. And this guy, and this guy should always be in any inclined plane problem. Please take note. So I will draw the same thing. So this is, so I need this. Similarly, I need this. This is mg. Then from here, so this is theta 1, theta 2. Then, okay, so let's assume here there is no friction. No friction, okay? Let's just do. Next video will be with friction. So this will be, now remember, this is tension. Again, this is, remember, it must oppose this. This is tension. So this will be mg. So for m2, this is m2, this is m1. m2 g sine theta minus t, remember the particle is going like this. So this minus this is equals to m2a, my first equation. Then this, obviously, this, any inclined plane problem, this particle is supposed to fall down. So that will always be there. Don't forget that. So this, you cannot say, oh, it's moving here. This will oppose this. So this will be t m1 minus m1g sine theta is equals to m1a. So these are my answers. You don't need to do anything. From here, just solve simultaneous equations. So remember, we're just showing you how. Once, for you to get to AS and A level, you should know your basics like quadratic solving, solving algebra, finding angles. Mainly algebra is the main thing. Algebra in any exam in high school is 60% of everything. It's everywhere. It's just for you to apply the concept. Then the next thing is to solve algebra. So your algebra should be very strong. So these are my answers. 6 now, so we're doing 6. In 6, we're doing the one with friction. So there's friction. So all of this will change. So I'm just going to erase it. It's going to change. Whether you say a bit change, a change is a change. Little is still a change. Okay? So now, since there's friction, friction is going to act opposite. Opposite. So this will be mu r. So this is coming friction. This is going like this. So friction, we act opposite direction. That is just what you need to know. Friction opposes motion. So for M2, for here, so I'm just considering from here to here. So M2G sine theta 2. So this is theta 2 if I didn't write it in the previous one. Please take note. So this theta minus T minus mu r is equals to M2G. That is it. You remember what R is? R is mg cos theta. Don't forget that. So this will now be, so this is the same thing as M2G sine theta 2 minus T minus mu mg. So M2 2g cos theta 2 is equals to M2a. This is A. MA. Remember, we're just using F is equals to MA. Okay? This is my final equation. So I will just check this and always check you're working. This R is M2, yes. Then for M1, this is going like this. So T minus mu R minus M1G sine theta 1. So this minus this is equals to M1 A. So we know what R is. So T minus mu M1G cos theta 1 minus M1G sine theta 1. So this is my second equation. So this and this is what I have. So all you need to do now is to solve simultaneously. Substitute your values. Trust me, when you do this in exam, you've gotten more than half of the mark because you know the concept. Any mistake you make from here is just algebra, nothing else. Do this, you get a mark more than half. So if this is, maybe this is 8 mark, you get more than 4 marks. You get 4 and 4, maybe 4 or 5. Everything from here is just algebra. So when you give a high school, maybe in year 10, okay, I give you these values. I've given you these values. Now you need to substitute. It becomes very easy. On doing the algebra masterclass, the connected particle masterclass. Okay, I was saying algebra because I'm also preparing an algebra masterclass from beginner to advanced. Okay, so watch out for that. So this is connected particle masterclass. What you need to know before your exam, don't do anything. Just watch this video. Trust me, watch the whole series. If you don't get this set of questions in your exam, hold me responsible. All right? Okay. Now, this is 7, I think. This is the 7th one we are doing. Okay, we're doing friction and no friction. So here, we are going to do no friction. So there's no friction. So the first thing we need to do, like we have been doing, we are going to find, this is M, the weight. And remember, this is the same thing as this. So this is always mg sine theta, m1. So this is m1g. So m1, m1g. This is r. Then all this. This is just the same thing as this. So you can draw the mass and do that. Okay. Now, action and reaction. This opposes this. Done. You don't need to think too much. Action, reaction, this and this opposite side. So for M2, this will be M2G minus T is equals to M2A. This is the first one we did. So you can check my previous video, you see everything. Now for this, what do we do? So this is going like this. So for M1, T minus, no friction, remember, M1G sine theta is equals to M1A. So that is so this minus this is equals to M1A because there is no friction. So next, we're going to do with friction. So this is my answer. Now, I'm just going to mix the videos together. So with friction, so this is no friction. Now, with friction, this will not change. So 1 is still there. So M2 is still the same. But M1 will change. So with friction, I'll just write so that you don't get confused. So this is M2G minus T is equals to M2A. So this is 3 with friction. I'll just call this 1 with friction so that we don't get, so this is first. For M1, this becomes T minus, the friction is this, mu R. Mu R minus M1G sine theta is equals to M1A. Again, we're just using F is equals to MA. You know what arrow is? Arrow is mg cos theta. Just substitute there, you get your answer. If you have any question, you can send it in the chat or just write the question paper here. We'll try to tackle it. All right, guys, have a nice day and bye. First, we're trying to resolve. We're going to do some questions soon. If you have any, just send it in the chat or tell me the question paper here. And don't forget to like this video and comment. Don't forget. Okay. First, this particle, let's say it's moving in this direction. Let's say it's moving like this. It's coming down. So, how do we draw? So this is, again, mg sine theta. So let me write it here. This is coming down. So this is mg sine theta. So m1, don't forget, down. This is always mg, doesn't change for inclined plane. This is action and reaction. This opposes this. So for now, no friction. You just do all of them. We'll do with friction. So this becomes M. So for M1, this becomes M1G sine theta minus T. This is T. This is T. Is equals to M1A. So this is my answer. So let's call this equation 1. M2. This is T. No friction. 0. Is equals to M2A. Done. Just solve it and you get your answer with the parameters given. Now, with friction, so everything is going to change. So for M1, so let's say there's friction here. So there's friction here and there's friction here. If there's no friction, just put that section as 0. So I would have just generalized it. So with friction, this becomes M1G sine theta minus mu R. Remember, mu R is always friction. And what's R? mg cos theta minus T is equals to m1a. So this is my first equation. For m2, we have T minus mu R. Okay, let me do the mu R for this. So the final equation will be m1g sine theta minus mu m1g cos theta minus T is equals to ma. So this is my final equation. Then for m2, what do we do? So we're going to do this. So T minus m, okay, minus mu R minus, okay, minus T minus mu R done is equals to m2g. What is mu R? Mu, we did something like this before. This is R, this is m2g. So T minus mu m2g is equals to, this is ma. This is ma. So always check your working. Even I can make mistake, but when I check, you know, the beauty about solving math is, even if you make mistake like this, the idea, when the idea is there, you don't lose maximum 2 marks. You lose mark for the answer and that step. Other things, so they will do carry forward. Okay, so m2a. So this is my final equation. Okay, so if there is no friction here, this section becomes 0, this section becomes 0, everything remains the same. So there was, okay, we're going to do friction. So let's say there is no, okay, let's do friction everywhere. So there's friction with friction. So be open to learning. Don't just always do something from your syllabus. Quadratic is the same everywhere in the world. Quadratic is same. I did another curriculum, so I'm teaching another curriculum. So those from China, imagine they are doing the same algebra, they are doing the same trigonometry. So that's why when you go for university admission, nothing changes. They are all the same. Okay. Okay. Now let's see. So I will do this first. So again, this particle is coming to this direction. So I will do both. So I will do the other side. So this is coming like this. So for M3, action, this is M3G, and reaction, this is T. Now let's see. So here there will be 2 T's because this is 1 T, this is 1 T. So T, remember I said this must oppose this. Now this is mg sine theta, so m1g, and so this will be T, this will be T. Opposite. So for M3, this will be easy. M3G minus T is equals to M3A. First equation, easy peasy. Easy peasy. Down, up, MA. For this, we're doing friction everywhere. If there was no friction, we'll cancel. For here, there's friction. So this will be M2. This is T also. So this is T1. This is T2 because these two tensions are the same connection. So this will be T1 minus mu R minus, so yeah, nothing else. It's equals to M2A. So this will be T1 minus mu M2G is equals to M2A. This is my second equation. Down minus up. Now for M3, for M1, this is going like this. So T, so let me, we're assuming there's friction everywhere. So there's friction here, there's friction here. T minus m1g sine theta minus mu r. So just for reference, we can call this R1. We can call this R2. So this is R1, so that we don't get confused. The arrow here is different from that. So R2, so let's see, this minus this. So this is friction is equals to M1A. So T minus mu M minus M1 G sine theta minus mu M1. So this is G cos theta. So that's R, right? Is equals to M1A. I will just check if I'm correct, okay? Because this is a little bit tricky. So T minus mg sine theta minus mu mg cos theta, yes. So these are my equations. From here, so if there's no friction, you cancel that aspect. So this is the final piece of the puzzle. This is the final piece. So I expect by now you have an idea. Don't just memorize, okay? Don't just memorize this concept. Understand what is happening. Don't cram. Don't cram. Okay? So have a nice day and take care.